All right, welcome everybody. Well, g'day, mate, as we say in Australia. Look, first of all, I'd just like to thank everybody for allowing this day to occur. I'd like to thank the Academy and Magnetic MRO, my employer, for giving me the opportunity to come here and speak to you today. So I've just got some introduction slides. So my name's Ross Loeng. First time to Europe, first time to Estonia. So been great so far. I really enjoy my time here so far. I included this slide. This was one of the favourite slides I got from Magnetic when I first put this presentation together. The one thing about the aviation industry is passion and drive. It's a difficult industry to work in. There's lots of complexity, but passion and drive in an individual will see you through. It makes it so much easier at 2 o'clock in the morning when it's freezing cold, it's pouring down rain, and you're trying to get an aeroplane dispatched, or you're trying to do a very complex task. So passion. So we are passion, we are driven, we are Magnetic. It's one of the things that drew me to work for Magnetic 12 months ago when I joined the company. Is I'm a great believer in the values of a business, and that's what drove me to join Magnetic. So I had to include a couple of their slides to the presentation. As you can see, the group I work with is with Camo Services and Technical Engineering. Here I am all the way down the bottom here in Australia, some 15,000 kilometres away, or 9,100 miles. So it took me a little while to get here. This is the third time, obviously due to COVID restrictions. This is the third attempt, and I finally managed to get here to visit the country and come here and have a look at the academy. So that's great. All right. So who am I? So I've been in the aviation industry for approximately 30 years. Worked on aircraft from little 2-seat Cessna 150 piston engine aeroplanes all the way up to 747 jumbo jets. Haven't worked on A380s, the larger later generation aircraft, but I started my time in aviation working on 747 aircraft in Australia. So I hold an Australian, what they call B1, B2 aircraft maintenance engineer's license. We also hold a private pilot's license. Worked in various roles in aviation regarding continuing airworthiness, which we'll discuss a bit further for those that don't really understand what continuing airworthiness is. I've worked in management positions, in maintenance organisations, in airlines, on boards, working through continuing airworthiness issues. And then later in my career, took a real passion to quality and safety. Now, our industry, as you know, is driven by safety. Without safety, we don't have an industry. It takes one accident and you can wipe your whole business off. So safety is imperative in our industry. And that's why I broke this presentation up into 2 separate parts. A part that just basically explains camos and maintenance, and the second part, which is purely related to safety and safety management systems. Also had experience in auditing, product auditing, aviation auditing, and dangerous goods. I was a dangerous goods on-call inspector for the airline I used to work for. So had quite a vast area of experience across aviation. So I'm really glad to see that a few of you came here today. Okay. Right. So that's where Business Australia is. That's where I normally live. Obviously, that's where telling us Estonia is. And by the way, airplanes don't fly in straight lines. So as you can imagine, due to recent issues, it was quite a long path. So it took me about 22 hours flying to get here. All right. So we'll get into the first section, which is continuing airworthiness. So like I start off the presentation with that second slide, is passion. So generally most of the people in our country have a genuine passion and enthusiasm for either flying or aircraft in general. So that's how they generally get into the industry. Quite often they have relatives that have been in the industry, and that can be over quite many different tasks. And like I said, sometimes when you work in this industry, you need to draw on that passion to keep you engaged in what you're doing and not just give up. So, look, as with all industries, you not only have to deal with the job, but you have to deal with continuous change. So, what you did yesterday may not be what you do tomorrow. Things change. So, regulations change. New systems get implemented, like what we're going to discuss in the second section, safety management systems. These things are forever changing and will change directly what you do in your role, wherever it is in aviation. You will see change happening all the time. And generally for people, it is very difficult to accept change. It's hard to understand the complexities that can come with, because at face value, people look at it and say, oh, we're changing this again, we're changing this again. But quite removed from the direct change is a safety outcome that you may not see. So just be prepared in this industry to experience change all the time. Of course, the information I'm giving you today really relates to how it works in Australia, but generally it equates equally across the aviation industry. There is so much commonality held right across the globe with regards to how processes are done. There's just slight tweaks on them in the different countries you go to. So we'll start with a camo. The best way for me to describe engineering camo services is to look at a basic structure. And for people that don't understand aviation, sometimes I even revert it to them owning their own vehicle. All right, so you buy your own car. And when you buy your own car, you buy a brand new car and you think, this is great, I can just jump in my car and drive anywhere. But if you don't maintain that car and it breaks down, you go, well, I bought a lemon. Well, maybe you didn't buy a lemon. Maybe you just didn't look after your car properly. So when it comes to aviation, we have these three areas, which is what I call oversight, control, and implement. So from the purpose of a car, we're saying the car has an owner. All right, that's me. I own my car. A continuing airworthiness organisation, right, relative to the car, trying to relate it to something that everybody understands, is the point that I need to maintain that vehicle in an appropriate way to an appropriate standard to ensure it's reliable. I can drive it everywhere. It doesn't break down. Unfortunately, with aviation, we don't get the choice of pulling to the side of the road and calling someone to say, my car's broken. Well, with an aeroplane, it's generally a long way home. And depending what it is, do you really want to be in the air? Like fires. You know, the last place, you know, what do they say? The only time you can have too much fuel on an aircraft is when you're on fire. So, yeah, so the control part of it is making sure that your car, or in this case, aircraft, is maintained in accordance with appropriate information and to appropriate standards to ensure it is reliable. The same with an aircraft. You're maintaining it. The CAMO, Continuing Airworthiness Maintenance Organisation, is maintaining control over the aircraft to ensure it remains safe and to make sure it's maintained in accordance with the data for that particular aircraft relating to keeping it in a safe condition. Now, because it's an aeroplane and we said, like I said, we can't pull over the side of the road when something breaks, they design a lot of redundancy into aircraft and aviation. So where you normally only need one system, you may have two systems or three systems. So there's a level of redundancy. If one system breaks, you still have remaining two systems to carry you on. So there is a lot of redundancy and safety built in to aircraft and aircraft design. So it generally doesn't rely on a single point failure to end up in catastrophe. It has to be a chain of events that occur. So that CAMO maintains that control of the product. So if it's car, the CAMO will ensure that When you send the car to the garage, it's maintained appropriately. Well, in our case in aviation, we have approved maintenance organisations, effectively the garage for the aeroplanes. So operator at the top who owns the aircraft, Camo in the middle, getting all the data together, putting all the jobs together to maintain the car/aeroplane, and garage, approved maintenance organisation, where they implement the directions given to it by the Camo. So the Camo will issue a work package out with heaps of technical information, and then the mechanics that work in the approved maintenance organisation or garage will carry those tasks out and report back to you, back to the Camo, to advise any difficulties or problems found. Now, I'll talk about Australia. So in Australia, we have operators who operate the aeroplanes, and the Camo must be a part of the operator. In Europe, it's a little bit different. There's contract services. You can actually contract the whole lot out. But we don't do that in Australia. It must be contained within the operator. So if you own an airline, your Camo is actually part of the airline. You do not separate them out or contract those services out. It's just what that's how Australian aviation has done it. So it does vary a little bit from country to country. So from a Camo perspective, which is what this presentation is about, we're going to just take you through how the Camo acts as that intermediate between the operator and the garage to ensure that everything's done right. And I love using practical examples of what happens occasionally. So very occasionally, you'll get something like this. And this is a picture from the National Transport Safety Board of a Southwest Airlines 737, where one of the turbine fan blades in the center of the picture there departed the aircraft in flight. So it had some sort of failure which caused that blade to fly out of the engine. It hit a window on the side of the aeroplane. The window blew out. Passenger got sucked into the window and killed. So that was a fatal accident. So if you had a similar aircraft in this case, or back to a car, relating it back to a car, if you had the same sort of car, how would you feel driving around if you knew something could fail that could kill you? You wouldn't feel that good about it, would you? So what do they do? So National Transport Safety Board send out an investigator. The investigator investigates why the blade flew out. So, this is a career in itself in aviation. We have mechanics, we have Camos, we have operators. Safety and safety investigation is a very specialised field, but it's a great field and very rewarding. I've done about 3 years' work in safety investigation, and it's so interesting to see that incidents like this are never the result of one point of failure. It's always a result of multiple points of failure. So in this case, they do their investigation and they find out that when these blades reach a certain age, they're more likely to fail than early in their life. So the Federal Aviation Authority in this case puts out a thing called an airworthiness directive. So these are documents that the regulators put out to ensure the safety of aviation. And so it goes to all the operators of 737 aircraft and says, if you have this engine with these types of blades at, I think it was 17,000 flight hours on the actual blade, you must remove the blade and carry out some special crack testing to make sure the blades don't fail. So that's done through what they call an airworthiness directive. Now, depending on how important it is, those airworthiness directives can be issued like that, 24 hours you must comply with the requirements, or they can have longer times to carry out the inspections depending on what the safety risk is. If it's a high likelihood that this is going to happen, they shorten the time right down. So, and when we do the second part, you'll hear me talk about risk mitigation and safety management. Effectively, That's what we do in aviation. An event occurs, we risk rate it and we say, what is the consequence of it failing? And what is the likelihood of it happening? Which gives us a risk rating for that item. So in this case, extremely high risk, likelihood was very high. And so once a blade reaches 17,000, you must do the inspection. So the manufacturer issues an airworthiness directive. Where do they issue it to? It's just a piece of paper at this stage going out to the operator back here. Back to the operator here saying, you operate a 737. It's got defective parts on it that have been involved. Well, not defective parts. It's had a significant failure in operation. Here's our recommendations of what we mandate you to do to your aircraft by a certain time. So the operator gets that notification generally through its camo department. The airworthiness directive will be assessed by the camo department, and it will say, rightio, we need to implement carrying out that task. So to do that, to actually carry out the inspection, we need to send it to our garage, to our approved maintenance organisation. And that's done in a formal structure, generally called a work package or a work order. So it will take all the requirements of the airworthiness directive, put them into a consumable document for the approved maintenance organisation to use, and to ensure that the engineers carry out the inspection in a certain way at the correct time and inspect those blades and ensure that they are safe for continued operation. So work package comes from here out to our approved maintenance organisation, back to the car, our garage. Please carry out an inspection of my fan blades. And they pull all the blades out. I think there's 24 of them in a 737 front fan. So they pull them all out and they do the inspections. And for each individual blade, they issue a report, a signed report to say there are no cracks. There isn't any damage as per the information contained in that airworthiness directive. Now, when I did have that there, I had an SB matters. The airworthiness directives are issued by the regulators. Now, those directives will normally say the manufacturer of the engine or the manufacturer of the aeroplane will issue their own form of literature which explains how to inspect the part. So airworthiness directives tell you there's something wrong, it needs to be inspected. Service bulletin will give you all the details of exactly how to carry it out, because that is done by the experts, the people that built it, the people that know the inside and out of the design of that blade. They will issue their service literature through a service bulletin. So the airworthiness directives is the part that tells you you must do it. The service bulletin is the bit that tells you how you are to do it. So from a very serious incident, we end up with a basic inspection in the aeroplane. Now what happens when they do the check, they go, oh, we've got 2 cracked blades. So we've got 2 broken blades that have got a detectable damage to them, which could lead to blade separation. So with that information that you get from doing your inspections, it actually goes back to the people who issued the airworthiness directive, the regulators, and says, we've carried out this inspection, we've got problems. We're starting to see lots of cracking. So what they might do is they might get this airworthiness directive and say, you were inspecting them at 17,000 hours, we now want you to inspect them at 13,000 hours, because we think there's actually cracking occurring earlier in the life of the blades. So when you look at our structure of operator, camo, approved maintenance organisation, this camo has a very important function to ensure these safety critical items are appropriately inspected. The information, the AMOs do the work, and the information and results are fed back to the camo and to the regulators to ensure continued safe operation. So that's just one example of something a camo, one of the functions a camo will do. is something like that event we looked at with the blade AD. So if you look at, this is another picture we've got from Magnetic. There is a 737 aircraft, and there's many different functions that a camo performs in regards to the overall maintenance of an aircraft. These are but a few. So engines, it's always good to have engines. Generally when the engines stop, everybody gets very nervous. Very nervous. So engine and engine management is really important. You know, without them, like I said, you can't do anything. You certainly can't fly. Landing gear and landing gear components. Obviously, these components of the aeroplane take a lot of strain, a lot of stresses. So again, ultimately, they have to be designed to sustain those stresses, and not only the normal stresses that an aeroplane undertakes, but well above the normal stresses that an aeroplane undertakes. So you've got to always have a safety margin built in to all the components that make up an aircraft. I'll give you an example. I spoke about the A380 earlier. In the initial design phases of the A380, they do what most aeroplanes do. They have to go through design stress analysis. And I don't know whether any of you have seen the videos where they bend the wings up, and bend the wings down, and bend the wings up multiple times. And those wings have to take an ultimate load factor of 1.5 times the maximum load they would experience in flight. When they first did the A380, it got to 1.49 and the wings blew apart into a million pieces. And they had to go back, redesign the wings so it would pass that certification test. I think it was 1.56 or something, the revised wings broke at. So there should be a lot of comfort in traveling an aircraft. It has lots of redundancy. It's got oversight of a camo organisation. It's got highly qualified people in the garage fixing it. Well, garage, aircraft maintenance organisation. So it does generally make for a safe operation, but it doesn't take too much for it to become unsafe. And in the second part, we'll discuss that as how multiple factors layer in to decaying some of those safety margins to the point where it can become unsafe. For our camo, so we've done engines, landing gear, interiors. What could possibly be complex about an aircraft interior? Really look at it. It's seats, it's carpet, it's plastic trims, it's cup holders, it's seat cushions. What could possibly be complex about that? Has anyone got an answer? I'll take a question for anyone. What do you think one of the biggest concerns you'd have about the aircraft interior would be?
Seats.
Eh?
Seats, how strong they are.
Yes, that's right. Sorry?
How to fit it all inside.
Yeah, true. Yeah, you get a lolly. Yeah, a lolly too. One of the biggest issues you've got is burn certification requirements. When these things burn, or if there's a fire starts in there, and you start getting the fumes coming off those fires, it can kill people. All right? And the certification requirements for interiors are extremely high because you don't want it has to pass certain certification test requirements before it even is allowed to be used in the aircraft. So flammability, noxious fumes, structural integrity of the seats is a very big one. It's got to be able to withstand basically a 9G, or the certification standards have changed a little bit, but basically 9 times the normal weight in those seats. And that certification assumed one thing, that everybody weighed 86 kilos. Does everybody weigh 86 kilos? Nowadays, I'd say not. But that was the certification standard when they first put it in. And it's been there for a long time. So they say that is the weight. They apply it to the force and say the seat has to withstand those strains. Well, unfortunately nowadays, you could end up with almost twice that sitting in a single seat. So, and at the end of the day, if you're going to be in a 9G crash, I think it's going to be pretty ugly anyway. So I don't think you're worried about the seat really falling apart that much, but you've got to have a standard. So that's the standard they apply. All right, base and line maintenance. So does anybody know the difference between base and line maintenance? Suggestion?
Yeah, base maintenance is the maintenance you do in hangar. Line maintenance is the one you
On the line? Yeah. Look, by definition, it's really more to do with the complexity of the tasks. All right. If you've got a lot of
checks and the
that's that sort of thing. It's a lot to do with the complexity of the tasks. So base maintenance are generally your longer periods, require lots of disassembly or have highly technical requirements where the aeroplane is going to be out of service for several days. Line maintenance is more your quick turnarounds between flights, defect management, and basic maintenance of the aeroplane to keep it operational all the time. But once it goes in the base maintenance, it's generally the larger checks, lots of disassembly, special equipment, work platforms and things like that. That's generally what is defined as base maintenance. So base and line maintenance are your maintenance organisation or your garage's requirements. Now the camo has to, again, put out instructions to both those areas to tell them what to do, how to do things, provide data for them to use to carry out those functions. Training is always, important in any organisation, in anything you do. You must have trained skilled staff. So again, it's a function that's required both for camo personnel, your garage personnel, but the people that often get forgotten are the people that do customer service the aeroplanes, catering, ground staff that push aeroplanes out, pull aeroplanes in, that do the receipt dispatch. Those are areas there that are also a concern of the operator back here. The person at the top who's running the airline. They've got to ensure all those people are appropriately trained. Because if they aren't, and they don't do things as they should, the aeroplane's broken, massive disruptions, and the people that have been saving their whole life to go on their 1 year holiday, or their once in a lifetime holiday, it just disappears. So training is a really, really important aspect of anything in aviation, particularly in camo and maintenance organisations. Important to have very well trained staff. Okay, let's see what we've got. We've done that one. That's the first part. Is there any questions from the first part? So it's about camo and engineering. No questions? If not, I'll move into safety management. Okay. So safety management systems. Principles of just culture and operational practical examples of safety management system. All right. So for years and years and years in aviation, you will always hear the term aeroplane crashed, must have been the pilot's problem, or must have been the pilot's fault. It's a human fault. He did something wrong. It never really, really looked at the true reasons behind accidents and incidents. So we're going to have a look at the basic fundamentals of the safety management system. But take a moment to think about the different risks and hazards that aviation has. Does anybody know what a hazard is in aviation? What's the definition of a hazard? I'm going to pick him. He's staring straight at me. So,
something unsafe.
a hazard basically is anything that can contribute to an incident or an accident. Anything. I noticed when we come in the room today, there's a slightly raised section on the floor of the door. That's a hazard. Because if you don't know it's there, you could trip over, you could headbutt the floor, you could do anything. They are all hazards. All right. And depending on the situation you put them in, with environmental conditions and lighting and things like that, will depend on how serious a hazard they can become. So the whole purpose of safety management is to look and identify as many of those risks and hazards that you see into a central reporting database, and making sure that the risk that those hazards pose doesn't become too excessive. And the appetite for risk is set way up at board level in companies. Companies who are responsible for their employees, their passengers, and their operation of their business have to set a standard for what risks they're willing to take. And then it flows down throughout your organisation, those risks. So obviously today, in today's generation of aeroplanes, we are quite different to the past years. We constantly operate 40,000 feet approximately, minus 48 degrees, and we jump on an aeroplane non-stop for 20 hours. Well, we didn't do that 50 years ago, but now we do. And the expectation of everyone that steps on that aeroplane is that it's safe and it will get me to where I want to go. And obviously from a customer point of view, with some nice plush fittings, and I get to sleep and I get to have a shower and all those other really good things. So, but like I said earlier, unlike a car, you can't pull to the side of the road when things break. So the design and the information that we use in our safety management system to reduce the risks of operating those aircraft to a point where it is an acceptable risk to take are really important as how it's managed. So safety management system is just that, it's a system for managing risk. And the more hazards and risks you can identify in what happens in your operation, the stronger and more efficient you'll make your business. Safety doesn't make you money, but it can save you a whole lot of money if it's done well and done appropriately. So when we look at the aircraft, we see it sitting at the airport terminal ready to go, and we think, all right, I'm about to jump on this plane, I'm going to be in the air for 20 hours. Before we even start to get on the aeroplane, there's a heap of important safety checks that have to be carried out for the aeroplane. We're going to look at one in a second where just one basic simple check got missed by a whole heap of people that saw it and didn't say a thing. And the aeroplane took off. The aeroplane had a serious incident, returned to land, landed safely, but caused a significant amount of damage. So, and the actual reason it occurred is obviously buried in the safety investigation report, but there's just some basic fundamental human factors that occurred on the day when the equipment that caused the problem failed to get removed. It should have been detected and it wasn't. So it was part of that pre-flight assessment for the aircraft. The other thing to remember about risks is risks can be very unique to locations. So, that step there today as we come in the door may not be a risk in this environment, but like I said, put weather around it, put dark lighting where you can't see, and the likelihood of you tripping on it is highly likely. So it can change very much depending on where it is. Okay. So where do we get the concept of safety? Well, safety management systems. The International Civil Aviation Organization sets the standard for aviation safety management in Annex 19. So it's an annex that lays out what the construct of a basic safety management system should be. Now, where I come from in Australia, we implement all the requirements of the ICAO mandate. So Australia, New Zealand and Canada were the first three main ones, and there's been a lot of progression from the others catching up. So I've got to take some cues for Australia here. But recently, there's been quite a lot of movement I've seen from the EASA. So it is growing. The integration of safety management, the full safety management system is growing right across the industry. It's a high growth industry. It's a high growth area in the industry because everybody realises the true benefit of it. And at the end of this presentation, I assume I can get a copy of this presentation to everybody. I'm going to send some key references of where you can get further information on safety and safety management. Because no matter what area of aviation you go into, you will see this. And you'll see this in motion. You should see this in motion. You should be worried if you don't see this in motion. Moving aside from aviation, let's step away from aviation. Do you know the most risky building site you never go onto is the one that has the sign up there that says lost time injuries 0. You know, maximum number of days since last incident, 376. You want to learn from incidents. You want to learn from positive. You want to learn from both the positive and the negative of events that happen in your workplace. So when something goes really well, you want to look at why it went so well. What were all the good things that happened and what did you learn out of someone's good experience? At the same time, you want your system to be capable of looking at the bad things. When someone maybe made an error, made a mistake, made a misjudgment, and what happened and what preventative steps you put in place to prevent that same thing happening again. And Tono and I had a discussion in the car on the way here, and we said, you know, as an organisation, if you do that, say, here today, we have an issue, we discuss it amongst ourselves and say, oh, yes, you know, we won't make that mistake again. We issue a memo out to everybody saying, hey, this never occurred. That's great to hear. What about our other 19 different schools, institutes, or whatever, which are part of our group if we were a large company? How do they find out about these errors? Or how do they learn from someone else's mistake? So safety management is a tool for this. It's a tool for being able to produce an environment or a culture in an organisation where people will freely report their errors. People will freely put themselves in a very vulnerable position without the fear of them losing their job, people laughing at them, embarrassing them. It's a maturity level which a lot of people can't handle. And putting your ego to one side and saying, hey, I'm human, I can make mistakes. Or I can be a victim of circumstances. You know, I might be concentrating on doing, there's a heap of other things going around me I'm not even aware of. And so learning from those experiences through a safety management system is really, really important. So next one. Okay. So in our OKO Annex 19, we talk about a systematic approach to managing safety. Right? Managing safety again, risk and hazards. Right? Risk and hazard, you identify something, you look at. What did I say? The two things you're going to look at for a risk or hazard. The likelihood of it occurring and the consequences if it does occur. So likelihood of me tripping over as I come in this environment, not a problem. At night, probably highly likely. The consequence, I'll fall flat on the floor and break my nose. So is that an acceptable outcome? Yes or no? No, it's not. Right, what are we going to do? We're going to install a sensor light. So whenever the light gets to a certain level, we shine a light on the step. You've just done this. You've put in defensive layers to prevent the accident happening again. So that is an example. And I always love looking at certain little things because you can apply it so much to what you do in general life as well as to your employment. The other one that I used once was when you get up in the morning and you're sort of half dazed and then you kick the corner of the bed and you hurt your toe. Effectively, the moment you step out of bed, you can practice risk management and look at how you're feeling and going, all right, I know if I go too close to that, I'm going to kick my toe, or I'll take a different path and I'll go around the end of my bed. That's how I use risk and safety management. This is what I teach to my kids when they look at what they want to do. Hey, I can speed down the driveway at 100 miles an hour without a helmet on, and 99 times out of 100, I'll survive it. What happens to the one time you don't? The car comes around and kills you. It's just a totally different mindset when it comes to safety and safety management. And there'll be people that say, oh, yes, you're naysaying and, oh, you're turning it into such a big thing. It's just got to be done in the right balance. And that's the hardest thing, trying to convince someone the correct balance between safety and finances in your business. So they call it a seesaw. So you've got safety on one side, money on the other. And you've got to make sure it's balanced. You don't want it going too far one way or too far the other, because you'll have the safest airline in the world, but can't make a cent because it's cost you so much to make it safe. Or you can have the other way. Poor safety, airlines making a lot of money for one fatal accident. And then all that's gone. The whole business is wiped out. So it's always a balancing act. So for safety management, the four fundamental agreed blocks of building it is safety policy and objectives, which is obviously set by the organisation, senior management, and they've got to put their full weight behind those principles. In other words, if you knowingly report that you've made an error and you report it through the system, it's not a punitive system. They don't just turn around and say, right, you made a mistake, you're fired. You'll hear me talk about a term called just culture. And once upon a time, that term was just sack them. Something goes wrong, you just sack it. Well, just culture isn't about that. Just culture is about acknowledging that people do make mistakes and things do happen. And so when that does happen, support them through a system, train everybody, let everybody know what's happened, the consequences of it, and don't turn it into an immediate sackable offence. There is one exception to that in safety management, and that is deliberate acts. If you deliberately go out of your way to do the wrong thing, you're not protected by just culture and the safety system. It's actually built into it. You deliberately go out of your way to break the rules, you're liable to termination and prosecution. All right. So a lot of people think, oh, well, all I'm going to do is slide in the safety report and that protects me. It doesn't when it's a deliberate act, when you deliberately go out of the way to breach the rules. So when you read procedures and practices when you're doing your job, and you think, you know what, I'm not going to follow that because I know better. All right. If you really, really take that to the nth degree of just saying, I don't care, you're the one that's going to get up in jar. So under a true safety management system, those sort of people don't get the privileges of understanding the system, working through the system and learning from your failures, because they are making a deliberate act to do the wrong thing. So safety objectives, safety risk management, we discussed about risk ratings and managing risk. Safety promotion, what do you think that's about? What do you think a good example of safety promotion would be? I can't see any in this room actually. Generally, it's materials that are laid around by the employer telling you about safety management and safety in the workplace. Encouraging reporting. One of the things I remember when I was an apprentice, there was a sign above the chief engineer's office, and it says, there is no such thing as a stupid question. In other words, you see something, you ask the question. Doesn't matter if it's, what other people may deem to be stupid. If you want to know, you ask it. It's a lot easier to explain than a stupid mistake. So safety promotion involves everything regarding your safety management system. How you tell your employees about it, where you put all your notices around your workplace, encouraging people to continually report about safety and safety-related issues, hazards. And fundamentally, it allows anybody in your organisation to report into the safety management system, whether it's a CEO or toilet cleaner, because they all have a different perspective of safety that they see on a daily basis. So manages risks in the business, don't produce income, prevent having to spend it, an investment in the long-term health of an organisation that produces efficiency and safety. This is another standard term I use all the time. The standard you walk past is the standard you accept. In other words, if you all walk past the bin and it's full, You all walk past and say, it's full, it's full. Whose job is it to empty the bin? A lot of companies will say, whoever walks past the bin, empties the bin, then they find out why the person didn't empty the bin, didn't empty the bin. And they find out, oh, the cleaner's on leave for 2 weeks. Well, what does the company do about getting somebody else to empty the bin for the next 2 weeks? So whether it's about emptying a bin or commonly in hangars, oil spillages, oil and fluid spillages on the floor, happen all the time. And everyone goes, oh, it's only a little bit, it'll be fine. How would you feel if your best friend, who you're working in hanging with for 10 years, trips over, breaks their leg, and they've got steel rods inserted in their legs for life? Because I know a guy that had that. He tripped on a puddle of fluid that big, and now he's got 2 titanium plates in his leg. So it happens. But heaps and heaps of people have walked past that same puddle over and over and just said, oh, it's someone else's job. They don't think to actually put some cones out or go get a mop or organise someone to fix it. They just walk by it. So the standard you walk past is the standard you accept, is one of the strong ones I also live by. So if you walk past it, you either tell someone about it or you physically do something about it before it becomes a risk to somebody else. Okay, we discussed just culture. All right, there's an atmosphere of trust. People are encouraged or even rewarded for providing essential safety-related information, but they also are clear about where the line is drawn between acceptable and unacceptable behaviour. Again, where you deliberately choose to breach a requirement or a rule. So with regards to safety management integration, you look at how it's applied across the whole company, and the fact that the chain of command, it's important for getting the message out right from above that it's fully supported right throughout the organisation. So these are some extracts out of the Australian requirements. The Australian requirements basically took the standard 4 that you see there, that are the 4 fundamental building blocks, and added some additional items to them. One of which was human factors, which has become a profession on its own in general industry. It's about human factors. So there's always a human-machine interface in so many things, and it's quite easy for those issues to break down. So when you do a safety investigation, you always do a full review of human factors and how they contribute to an incident or an accident. So in Australia, we added 3 additional ones. Flight data analysis was another thing. The more complex the aeroplanes become, the more they monitor all the different flight parameters of the aircraft. There's flight data analysis programs that airlines run that look at the complete flight of the whole aircraft and look for any obvious deviations from their standard procedures. Because every time you vary from what's a standard procedure or a process in your manuals, you again run the risk of an incident or an accident. So they use that data, the analysis of that data, to try and find different incidents in their aircraft operation if they're not reported. So, of course, the pilots operating the aeroplane or the engineers fixing them, when they have a problem, should be reporting it. As much as the safety management system is about, remember, between the line of acceptable and unacceptable, it is actually unacceptable not to report safety issues. In my employment contract, well, not with I'd have to read the policy on that. But several organisations I've worked with have a clear statement that say, if you do not report a safety-related issue, it's a termination-related event. And that's how you can get, a lot of good participation in your safety management system, is by saying, not only should you not walk past the particular safety issue, if you fail to do anything about it, you are just as culpable as the person who made the incident in the first place. All right, you have to report. It's going to be very hard to prove because 100 people might have walked past that puddle on the hangar floor, but that is part of the fundamentals of building the system, is that you make it very clear to everybody. It's not just a requirement when a safety event happens that you report it. They also want you to proactively report safety related issues. For those of you who love going to the movies, has everybody seen that? Everybody seen the movie? Sorry?
With Tom Hanks.
Yeah, that's the one. You're on the money. Cactus 1549, Landing in the Hudson River, is my absolute favourite movie for getting anybody who doesn't understand a lot about aviation to understand safety management 101. All right, put in a terrible location. Both engines have stopped. We started talking about that at the beginning because he ingested birds into both engines. And he ends up landing an aeroplane in the Hudson River and no one dies. All right. But the point I want, if you haven't seen the movie, the points I want you to take, if you ever see it for the first time when you explain it to somebody, is just listen to a lot of the things he says in the movie about teamwork, communication. You know, all the technical data in the world said, you've done the wrong thing. Well, it turned out he didn't do the wrong thing. And all the evidence proved he didn't do the wrong thing. So to me, it was a really fantastic movie to explain how safety management systems should work. And the fact we are all humans. And if you put a human into a unique situation, they are all going to react slightly differently. It is when you put people under a lot of pressure in extreme situations that they're not trained for, you can't expect them just to do, oh, yes, you just go to left, go there, do this, do that. Because the human mind has to understand what's going on, look at all the information, and those vital few seconds be the difference between a major incident by accident, a total wipe out of the aeroplane, and it going a lot better as it did in this case. So he on that day took the Hudson River as the perfect place to land the aircraft. Everybody walked away safe. Yeah, sure, the airline wasn't impressed about it, the insurance company wasn't impressed about it, but he was confronted with something that no pilot has ever been confronted with in that situation. And at the end of the day, no one died. And that's the great thing, no one died. Might have cost people a bit of money, but no one died. I use these couple of other items, item 1 and 2, as demonstration of safety management. The missile defence one was something I learned in a short stint I had at a defence contractor over in Australia. And it looked at a simple scenario where President of the United States in his Air Force One has a missile defence system to shoot down incoming missiles if someone shoots at it. And the organisation couldn't work out why this missile defence system in the president's plane kept on failing and costing them millions and millions of dollars to maintain. Couldn't work it out. So they went to the contractor, who I used to work for, and they said, we need to find out why this system keeps on malfunctioning, burning out and costing us millions of dollars. So the investigator said, all right, I want you to get me everybody in the room that's had anything to do with design, the build, and the maintenance of this system. So they got them all in the room. So we've got the highly degreed design engineers at the back who, did all the magical sums and numbers and worked out how the system would work. We've got the people that built it, the people that tested it, and then we've got the people that maintain it and do all the regular maintenance on it. So I'm all in the room and they say, this is the scenario, it's costing us millions, what are we going to do about it? And guy in the corner of the room puts his hand up and the guy goes, okay. And the investigator says to him, what do you do? He says, well, my whole job is in the nose of the aeroplane, under here, where the defence system is, there's a scanner that goes side to side and it needs lubrication. So my whole job is to go up there, open it up, pump the grease in, and clean up the mess underneath, walk away, it gets closed, and that's all I do. And all of a sudden, all the design engineers at the back are going, what did they just say? The system was designed so it should never have anything to clean up after the job. It was a fully contained system to such a high standard that you should never have any debris left after when you do the last task, which is to lubricate. And what they actually worked out was the fact that the old grease that was coming off the drive system was getting into the internals of the firing system and making it blow up. The guy who greased the gears that drive it side to side, not the design engineers, the guy that greased the gears, had a crucial piece of information to fix a multi-million-dollar problem. Full-blown safety management systems, full-blown investigation. You need the right people in the room, because if you're asking the wrong people, you're never going to get that answer. That was one good example. The shimmer effect is, anybody seen a movie called Deepwater Horizon? Again, another good example of safety management. An oil platform that exploded. There was a heap of underlying safety issues relating to the operation of the platform. Well, this is a story about a young guy it was his first ever day out on the oil platform. And they had so many warnings and sirens and devices on these platforms, warning about oil leaks, gas leaks, and all these different things, that it can be a very dangerous place. Once a fire or something like that happens, it turns very ugly very quickly. So the shimmer effect story relates to a new person. It's his first time out on the oil platform. So he's flown out in a helicopter. He gets off the helicopter. It's a really sunny day, and there's a heat haze. And he mistakes this as a gas leak. And he goes over to the big red button on the wall that shuts off the whole production of the platform and slams it and shuts the whole oil platform down for 2 days. Cost the company millions and millions of dollars. What do you think happened to him? Does anyone want to take a guess?
Nothing was rewarded.
Exactly. He was rewarded for what he did. Right? So he got called to the main head office, called in the office, and he thought, well, I'm being sacked. Maybe they're going to send me the bill for all the expense I've just costed the company. No, they rewarded him. They gave him a $30,000 Rolex watch because he actually thought he saw something that was could have been serious and catastrophic for the company, and he was prepared to go over and hit the switch, which they're all trained to do. Sure, it wasn't the greatest outcome for the business, but the fact he was willing to do it showed the company that their SMS safety management training throughout their organisation was effective. People would take the authority and go do something without having someone tell them to do it. And in the Deepwater Horizon movie, there's a scene in there where they could have cut the fire off, but they said, no, you haven't got authority to push the button. So safety management systems should allow those people to see an error, detect it, push it. Because the results, if you don't do it and it is a gas leak, are just catastrophic. And nobody wants that. All right, and this is the last example. So this is a Malaysian Airlines A330 in Brisbane, Australia, where I come from. So in Brisbane, Australia, it's pretty tropical, it's pretty warm. Like we're in winter now, our top temperature is 25 degrees. So this is, what we define as cold. The biggest problem in Brisbane, well, one of the biggest aviation problems that they tend to have in Brisbane is European mud wasps, or mud doubler wasps, they're called. So the little wasps, and we get them all around the airport because it's very swampy, watery land. So, and what they love doing is in the front of the aeroplane here, there's these things called pitot probes. So they're probes that take outside air pressure into the systems in the aeroplane to tell the aeroplane how fast it's going, how much it's climbing. It's really important, vital information for the flight crew to use to fly the aircraft. And because of this wasp problem that they've got at Brisbane Airport, One of the requirements is at each time that they come in to offload their passengers, refuel and do all that, they fit these little plastic covers or carbon fibre covers or whatever they're made out of, red flag covers to go over the pedo probes to prevent these little wasps from flying in and making their nests. The wasps in the research they did around Brisbane Airport take 20 minutes to completely clog a pedo head, to make it completely unusable. So the mandated use of these flags during turnarounds was a really big thing for Brisbane Airport. To this day, some operators still do not cover their probes because they believe the risk does not exist. But I did 2 or 3 investigations physically with people with cameras showing pictures, and they even had CCTV footage from the gate cameras of the wasps physically flying in, building the little nests and flying back out again. So it's a very real risk. So anyway, they were fitting covers. As soon as the aeroplane came in, the probes were cool enough, they fit the covers on. Now, some airlines have good procedures, which have active steps in place to ensure that those covers were always removed prior to the aeroplane being pushed back. Others have not so good procedures. In this case, I believe there was a confusion relating to who was responsible for removing the covers, and the covers never got removed. So in other words, the aeroplane here, you've got people all on the ground, the flight crew have done their walk around prior to departure, and they go, oh, that's okay. The guys will come and, pull these off at T-5 minutes before departure. Well, it didn't happen. So the aeroplane got pushed out. Go take off. Pushed it down. Aeroplane taxied away, went to take off, takes off. All the alarms and bells and everything are ringing saying there's something wrong. So flight crew keep going and take off. So they take off, come back around, land, and due to those little plastic covers here still being fitted, caused a lot of damage to the aeroplane. Simple plastic covers that were actually put in to make it safer for the aeroplane ended up causing an accident. Again, SMS 101, if we take an action, we've got to risk assess what the risks of taking that action are. So yes, we've fitted the covers to stop the wasps going in there, but how are we going to make sure they get removed before the aeroplane goes flying again? So whenever you change something, so remember I said earlier, you're in an industry where you're always going to see change. You've also got to consider what the effect of that change is going to be. Whether it's going to have a positive safety effect, negative safety effect, and what additional procedures you may have to put in place to ensure that your preventative issue doesn't actually become a risk in itself. Any questions on safety management? I'm getting lots of interesting faces, so that either means they're thinking about it, which is really good, because you'll see so much more of this in your lifetime than I will, because it's a quickly developing area of the industry. I won't do those final twos. This was the airline I used to work for, Virgin Airlines in Australia. This was actually a fuel leak on an A330 that had some maintenance carried out on it. And that picture there, on the day this occurred, there's actually a news channel out there doing some file footage for a telecast, and they took a picture of that. At the same time they took that picture, an engineer driving on the outside of the airport saw it, rang it in, reported it. A member of the public saw it, rang in and reported it. Air traffic control rang in and reported it. So there was multiple people reported this fuel leak. It got about 100 miles away from the airport, and the crew said, okay, captain walked back and goes, yes, there's fuel leaking out of the engine. So they shut the engine down. It's a twin engine aeroplane that you see. Aeroplane returned to land. Now on that day in Melbourne, there was a 50-knot crosswind. So here is an aeroplane flying on one engine in a 50-knot crosswind. Very, very difficult. Could have ended up very ugly. That fuel leak, again, I did the investigation of that fuel leak, had about 14 different individual factors that went into that fuel leak occurring. Some of them so simple and basic that it should have been done, and it also should have been in the manuals for the aircraft that would have prevented that from happening. So I suppose from what I spoke to you about earlier, just be aware that accidents are generally never ever caused by one thing. It's easy for people to say it was him, it was her, or it was because this part failed. It's normally there's a heap of other organisational issues and underlying issues, and they're the things that you want to get out of your safety investigations and the safety management system to prevent those sort of events like that fuel leak. Because the last thing anybody wants is you land and you end up with that, which is fire on the whole wing, emergency evacuation. When you've got to emergency evacuate an aeroplane, people get injured or even killed. So, you know, ensuring that we're back at just a simple fuel leak and we do an investigation, find out the underlying causes and put in additional preventative actions are really important. So the last thing I'll do, so these are the references that I spoke about. So the EASA, Annex 19, further information, there's a website there. This is Tony Kern. So he's the guy that first got me into safety 25 years ago, and that small airline I was at. Sydney Decker does a lot of great work about just culture and education, and there's lots of information about him online. And James Reason, the Swiss cheese model. And the Swiss cheese model is about saying that from an accident to an incident, and there's a whole heap of layers of defences that have to fail before it becomes an accident or incident. It's not about one thing. So I'll make sure you'll get a copy of this, and then if you wish to, you can go and have a look at it further. But it's a very interesting area of the industry, and if it really takes your fancy, by all, follow it all the way through, because it's very rewarding, or I find it very rewarding when you can look at a problem and find multiple deficiencies and multiple solutions to help you overcome those deficiencies. And that's it for today. I hope you all enjoyed the presentation. So that's my take on it. You know, obviously, the more different opinions you get from all around the world of safety management, camo engineering, you know, to help you make a decision. But certainly from a camo engineering and safety management point of view, it can take you anywhere. Anywhere in the world. You can go all over the world. And, you know, safety management, camo engineering, yes, there are technical aspects to it, but they're quite different to being an engineer directly fixing a plane or other roles within the industry. So I hope you got a lot out of today. Thank you.